Hello everyone, this is Dr. D. Rajalakshmi, Associate Professor in CSE Department of RMD Engineering College. In this session, we are going to see about dynamic programming technique in design and analysis of algorithms. Dynamic programming technique is a general algorithm designing technique for solving optimization problems. It is solving the problems by defining recurrences with overlapping subproblems. It is invented by American mathematician Richard Bellman in 1950s. The main idea behind dynamic programming technique is set up a recurrence relating a solution to a larger instance to solutions of some smaller instances. Solve smaller instances once. Record solutions in a table. Extract solution to the initial instance from that table. We are going to solve coin changing problem using dynamic programming technique. In the case of coin changing problem, a list of integers representing coin denominations and another positive integer representing an amount of money will be given as input. And a minimal collection of coins of the given denominations which sum to the given amount is the output. We have to give change for the given amount n using minimum number of coins of denominations given to us. This is what is the coin changing problem. This problem is going to be solved using dynamic programming technique. This is the example problem. Here, the given amount is 6 and the denominations are 1, 3 and 4. This is the recurrence equation we are going to use for solving coin changing problem. F of n is equal to minimum of f of n minus dj plus 1, where for all n greater than 0. And f of 0 is equal to 0. This is what is the initial condition, where n is the amount for which we are going to find the change and dj represents the denominations. The condition for applying denomination is n must be greater than or equal to dj. We can apply the denominations that are satisfying this condition in this recurrence equation. The initial condition is f of 0 is equal to 0. That is, for 0 amount, the number of coins required for change is 0. Now, this is what is the table structure. Number of columns needed here are 0 to n. If n is equal to 6, then we need 0 to 6 columns and 1 row. Columns represents, the column value represents the amount for which the change is going to be found. And the row represents the number of coins required for the change. So initially, for 0 amount, what is the change we need? That is 0 only, that is given as initial condition. So that value is written here. Then we have to find the change for 1 amount, for the amount 1. So f of 1 we have to find. Now from here onwards, we have to apply the recurrence equation. Minimum of f of, what is n? N is equal to 1. So 1 minus denomination, we have to substitute. 3 denominations are given to us. All the 3 denominations cannot be used here in this step. What is the condition for the denominations? N must be greater than or equal to dj. Okay. What is n? N is equal to 1. Which denomination is satisfying the condition, that is n greater than or equal to dj? Only the first denomination. That is, amount 1 is greater than or equal to the denomination 1. So here only the condition is satisfied. So only that denomination is going to be used here. So minimum of f of 1 minus 1 plus 1. What is f of n? 1 minus 1? It is going to be f of 0. F of 0 is equal to 0. We are substituting that value 0 here. 0 plus 1 is 1. So that 1 is written here for f of 1. Now in the next step, f of 2. We have to find f of 2. For the amount 2, what is the change we are going to find? What is the number of coins required for the change? minimum number of coins required as change. That is what we are going to find here. So n is equal to 2 here. When n is equal to 2, what are the denominations of satisfying the condition n greater than or equal to dj? Here also only one denomination, that is the very first denomination, 1 is satisfying the condition. So that is alone is going to be applied here in the recurrence equation. Minimum of f of 2. What is n? N is 2. And what is dj? Which is satisfying this condition? It is 1. So we are applying, we are substituting 1 here. Plus 1. With the result of this part, 1 is going to be added. So f of 2 minus 1 is going to be f of 1. What is the value of f of 1? It is 1. So that 1 is added with this one, we are getting 2. So what is f of 2? F of 2 is equal to 2. That is written here in the table in place of f of 2. Now in the next step, we are going to find the minimum number of coins needed as change for the amount 3. F of 3 we are going to find. We are going to find the change for the amount 3 with minimum number of coins. So minimum of f of, what are the denominators we can use here? Denominations we can use here, 1 and 3 can be used. So f of n minus 1, comma f of n minus 3. Which is minimum? We have to apply the formula here. F of 2. F of 2 is 2. F of 0. F of 0 is equal to 0. The minimum is 0. So minimum value we are taking from this part. That is added with 1. We are getting 1. So f of 3 is 1. That is written here in the table. In the next step, we are going to find the change for the amount 4. N is equal to 4 here. What are the denominators are satisfying here? Denominations are satisfying here. All the 3 denominations are satisfying the condition n greater than or equal to dj. So we are substituting all the 3 denominations here. So f of 4 minus 1, f of 4 minus 3, and f of 4 minus 4. Which one is giving minimum value? F of 4 minus 4, which is equal to 0. That is what is the minimum value. So with that minimum value 1 is added, we are getting 1. So f of 4 is also equal to 1. That is written here in the table. Then we are going to find the change for the amount 5. F of 5 we are going to find. Here n is equal to 5. Here also all the 3 denominations are satisfying the condition. So we are substituting all the 3 denominations here in the formula. So minimum of f of 5 minus 1, f of 5 minus 3, f of 5 minus 4. What is f of 5 minus 1? F of 4. The value of f of 4 is 1. F of 5 minus 3 is f of 2. F of 2 value is 2. F of 5 minus 4 is 1. F of 1. What is f of 1? That is also 1. So the minimum value is 1. 1 plus 1 is 2. So that is written here. Now, in the next step, we are going to find f of 6. For the amount 6, what is the change? That is what we are going to find. Minimum number of coins required for the change. That we are going to find. So n is equal to 6 here. Here also all the 3 denominations are satisfying the condition. So we can use all the 3 denominations here. F of 6 minus 1, f of 6 minus 3, and f of 6 minus 4. Only the second denomination, that is if this part, f of 6 minus 3 is going to give minimum value. What is f of 6 minus 3? It is going to be f of 3. What is the value of f of 3? F of 3 is the minimum value is going to be, f of 3. F of 3 is 1. So with that 1, this 1 is going to be added and we are getting the sum as 2. So that is what is the value we need. That is what is the number of coins we need for the change of the amount 6. So that is written here. Now this is the solution. 2 number of coins are needed for the change of amount 6. And we can backtrack this table in order to find the coins, the exact coins of the change. When denomination is equal to 3 only, we're getting this minimum value. So the coin we need for the change is 3. Okay, then subtract 3 from this n, we are getting 3. So now we have to go and search f of 3. So which denomination is giving minimum value here? Here also denomination 3 is giving minimum value. So the second coin in the change is also equal to 3. So if you subtract 3 from here, it will be 0. So that's it. F of 0 is equal to 0. So two number of coins with the denomination 3 are needed for the change of the amount 6. This is what is the solution to this problem. Now this is what is the algorithm. Here to this algorithm, list of denominations and the amount for which we are going to find change. Both are given as the input. Initially, for 0 amount, the change required is 0. So that is stored here in place of f of 0. And using this for loop, the recurrence equation is going to be applied. Here I represents the amount for which we are going to find the change. Okay, I is taking value from 1 to n. Okay, so actually we need to find change for the amount n only. That is going to be solved using dynamic programming technique. It is solving the problem using overlapping of subproblems. Okay, so initially the subproblem with n value 1 will be solved. Then subproblem with n value 2 will be solved. Then 3, 4, 5, etc. At last n will be solved. Okay, so when I is equal to 1, for the amount 1 only, we are going to find the change. Okay, so which denominations and all can be used? N greater than or equal to dj. The denominations that are satisfying these conditions are going to be used. That is checked here. And then we are finding the minimum value, and that is going to be stored in the variable 10. This will be repeated for all the denominations. At last, whatever the minimum value we are getting, no, that will be added with 1. That's it. So that is going to be stored in the f of I position. This will be repeated for all the iterations, and at last f of n will be found, and that is what is the solution for this problem. In this way only, coin changing problem can be solved using dynamic programming technique. Thank you.